And good afternoon, everybody. Welcome to World Summit AI Insights, our series of webinars for our AI community. I'm Vidya Gunapala, Chief Content Officer at Inspired Minds. Today, we have a webinar for you in partnership with SAS, looking at 5 real-world AI success stories. We have a 30-minute pre-recording from Georgios Kapetanvasileiou, who's the lead data scientist at SAS. Then he'll be joining live for 15 minutes of Q&A. Georgios will be highlighting the value AI can drive for organizations across a range of industries and discussing how we can use different approaches to ensure that our AI applications are actually explainable, they're ethical, and they're well governed. If you have any questions as the presentation's going on, please can you type them into the chat function and I'll present them to him during the Q&A. So over to you, Georgios.
Thank you very much. Welcome everyone to today's webinar. In this webinar, we will explore what artificial intelligence is, why is it different from traditional approaches, go through some real AI success stories of organizations that are actively using AI solutions today, discuss the topic of AI bias, and finally look at how we can start validating the results of any advanced machine learning algorithm. But let's start with a bit of an overview. So the terms AI, artificial intelligence, machine learning, deep learning, and natural language processing have been around for quite some time now. AI as a term was coined in the 1950s after all, with the first implementations of neural networks. So what has changed over the past few years? The size of the data has increased. As more and more of our world is getting digitized, companies get access to larger volumes of data that they can use to add value to their products or services. The variety of data has changed as well. So today we not only talk about structured data, but we also talk about unstructured data sources such as images, videos, or speech. The computing power revolution as well, that has allowed us to run complex, highly advanced algorithms within acceptable timeframes. So I tend to think of AI as an umbrella term that covers the broader science of training intelligent systems to perform human-like tasks. Machine learning is a branch of AI that deals with the approaches that automate analytical model building. Deep learning is an extension of machine learning that focuses on teaching machines to recognize patterns in unstructured data sources, such as images or video. And last but not least, NLP, natural language processing, which is another pillar under AI. NLP helps computers understand, interpret, and manipulate human language. So what is artificial intelligence? AI at its core automates the process of taking large amounts of data, whether from structured data sources like traditional tables or unstructured sources, running them through complex algorithms that analyze them and identifying interesting patterns within them. At the end, once the data is analyzed, an AI system can reply it back with an intelligent response or prediction to facilitate our decision-making process. But why is AI different from anything else we had before? Well, the real power of AI is that it learns by itself, without us as humans having to explicitly tell the system what to look for. The entire learning process happens automatically. Let's say, for example, we wanted to build a system that automatically predicts heart disease cases, like the example above, when presented with patients' data. In the past, if I were to build a system like this, I would have to sit down with a doctor and try to capture every likely scenario with explicit rules, which I would have to hard-code in the computer, like the example here. As you can imagine, that would be a very manual, time-consuming process. Enter AI, which can considerably speed up the whole process. An AI system can automatically identify and write these rules by itself, on its own. The algorithm will go and figure out by itself what contributes most to heart disease and how that can affect the final prediction. All I have to do is make sure I provide it with sufficient data of heart disease cases to learn the differentiating factors of this condition. As you can see in this example on the screen, the AI system identified and wrote these rules by itself. I just contributed by dragging and dropping the data. So what is machine learning then? Well, machine learning is the process that powers AI systems. If artificial intelligence is the end goal, I tend to think machine learning as providing the means for achieving it. Machine learning are the algorithms that, using a sequence of statistical processing steps, are trained to determine patterns and features in massive amounts of data. Once a machine learning algorithm is trained or learns from historical cases, it can then be used to infer decisions or predictions based on new data. Let's now look at how machine learning algorithms are trained. There are two real main approaches that I would say cover 95% of all cases of machine learning implementations in the field. Supervised learning being one of them. So in supervised learning, machine learning algorithms are presented with historical data that have been pre-labeled, meaning we tell the algorithms what the outcome of these historical cases were. Let's say, for example, that I need to train an algorithm that can differentiate between cats and dogs, like the example above. To do this, I would have to present a computer with thousands of example images of cats and a separate sample of dog images. And that's where my responsibilities ends, because just like the human brain, the computer will go away and learn by itself what the key differences between cats and dogs are. Once the learning process ends, the produced algorithm can be reused on new images to infer whether the animal depicted is of a cat or a dog. We typically use supervised learning approaches for regression problems, like predicting the prices of houses, or classification problems, let's say a probability of loan defaults. So here are a few examples where supervised learning algorithms are utilized today to assist decision-making processes across different industries. For example, risk modeling. In risk modeling, in banking or insurance, machine learning helps identify if someone is likely to default on their loans, or from an insurance perspective, whether he or she is likely to be involved in a car accident. Fraud detection to identify suspicious activity during credit card transactions. Demand forecasting in retail for predicting demand of products in stores. Predicting whether someone is about to cancel their subscription contract from a customer retention perspective. And also document classification, where the goal is really to predict the topic of a given piece of text. So let's now move on to some real-world applications of machine learning. This is the first real-world example of a UK insurer who is using supervised learning algorithms to calculate risk more accurately in order to present customers with a fairer price when quoting for a new car insurance policy. Motor insurance pricing is currently a very competitive business, with every insurer trying to outsmart their competition. Typically, this process for insurers is very manual. They rely on more traditional approaches, such as generalized linear models, which tend to involve a lot of manual steps, but also fail to achieve high accuracy. By introducing more advanced machine learning approaches, such as gradient boosting, this particular insurer was able to see significant uplift both in accuracy and automation, allowing them to gain a competitive edge over their rivals. Next up is the example of Nestlé. And Nestlé, as you might know, is the world's largest food retailer. Nestlé each and every day needs to make sure that the right amount of products reach the shelves of various stores. The perishable nature of their products makes it even harder for them to make demand decisions and plan logistics. It might sound even more challenging when you consider that 1 billion units leave Nestlé's production line every single day. If they forecast too much, it's difficult to find storage space, and also the freshness of products might suffer. On the other hand, if they forecast too little, they may not be able to meet demand and service levels will suffer. Using SaaS forecasting solutions allows Nestlé to run multiple models across multiple stores and regions, make better production decisions, But more importantly, since the whole process is mostly automated, Nestle's analysts have more time to focus on other value-added tasks. So that was supervised learning. What about unsupervised learning? In unsupervised learning, an algorithm is presented with data that have not been labeled, so we're not giving the algorithm the answers. The algorithm is merely asked to identify the relationships within the data and identify any interesting connections between them. For example, we can identify groups of data that behave similarly, and we can use that to discover natural clusters. Or, on the other hand, identify outliers or abnormal behaviors that look considerably different to the rest. So what can we use unsupervised learning for? We can use it for segmentation to get a better understanding of my customer base, customers that have similar behaviors. For recommendation engines, like those that Netflix or Amazon use every day to recommend us with new products or services. For anomaly detection, to uncover abnormal behaviors, for example, in fraud detection problems. Predictive maintenance, for asset management, to proactively identify asset failure before it actually happens. And dimensionality reduction, for feature engineering or selecting variables when dealing with thousands of different features. Volvo Trucks is another great story of how organizations can use analytics for predictive maintenance. So Volvo is using SAS today to collect and analyze streaming telematics data in order to proactively run diagnostics and monitor the condition of the truck engines in real time as they move through the streets. If an issue is detected, an alarm is raised, and service agents need then to determine whether to keep operating the truck on the road or send it back to a garage or servicing. SAS Analytics has helped Volvo reduce diagnostic time by 70%, but also reduce repair times by more than 25%. As you can imagine, minimizing unplanned downtime is critical for businesses like the one Volvo Trucks is operating. Okay, let's now move on to deep learning. And deep learning, as we saw earlier, is a branch of machine learning. It's used for solving complex problems, including identifying images of objects, speech recognition, and these algorithms tend to be very powerful. They can also be used for solving traditional business problems in more accurate ways. Let's look at the example of Amsterdam University Medical Centers. Amsterdam UMC is one of Europe's largest academic oncology centers, and they tend to face many challenging problems, like for example, after a period of treatment such as chemotherapy, medical professionals have to manually evaluate tumors using computerized tomography scans or CT scans. They have to diagnose if the tumor shrunk or changed in appearance at all. How the tumor reacts to therapy determines whether life-saving surgery is possible or different treatment is necessary. This manual process presents many challenges. Evaluating tumors is a time-consuming process to start with for radiologists. Also, it's a very subjective process, resulting in variations between practitioners. And unfortunately, it's also prone to human error, leading to unnecessary surgery or chemotherapy. Together with SAS, Amsterdam UMC uses computer vision technology and deep learning models today to increase the speed and accuracy of chemotherapy response assessments. And also the capabilities like auto-segmentation help doctors quickly identify changes in the shape and size of the tumor. So another story or example where we can see that AI can make a significant impact to everyday lives. Let's now look at natural language processing. And as we saw earlier, natural language processing enables understanding, interaction, and communication between human and machines. It plays a key role in utilizing structured data, such as text, which has a huge potential because you can find information that is not stored in traditional data sources like structured data. Let's look at an example. So RBS, or Royal Bank of Scotland, is another example. They had recently launched an online portal through which customers could communicate with agents, known as web chats. As web chats grew in popularity, they wanted to ensure that this channel was providing customers with excellent service. And to do so, they wanted to get a better understanding of the various conversations taking place in this digital channel. What were the customers talking about? What were the key challenges their customers were facing? However, they discovered that they could only review 200 of the 250,000 manual monthly web chat conversations. So the sheer volume of this channel made it, and the sheer volume of data through this channel made the manual analysis of all the chats impossible. Today, using NLP, RBS is able to automatically determine the conversation topic, but also analyze the sentiment behind the conversation, behind the conversation with their customers. They can understand customer objectives and which queries agents typically struggle with, which helps them to offer feedback back to their agents, but also offer more targeted training to their employees. As effectiveness increases, this NLP automation also eases inbound burden of call centers. So these stories we covered above are just a few examples of how AI can produce value and raise productivity for businesses across different industries. They demonstrate the impact AI can have in everyday life and on our choices and decisions. That being said, then, raises an important question. Can we really trust AI? And can AI be biased? Let's look at a simple example. What do you think happens when you do a simple image search for the term CEO or Chief Executive Officer in some of the web's most popular search engines? I've tried this to have a look. So the first one is from Microsoft's Bing, and as you can see, the top results are all reserved for male CEOs, which is indeed surprising when you consider that women CEOs account for almost 8% of Fortune 500 companies. Trying the same in Google, and as you can see, Google does a better job with Indra Nooyi of PepsiCo and Meg Whitman, which is a former HP CEO, making the list. I've also tried it to China's largest search engine, Baidu. I tried the same search. What do you think the results look like? As you can see, trying the same search in Baidu leaves you having to scroll further and further before you come across a female image. In fact, AI has been getting really bad PR recently from news articles like the ones above. They are all about how bias and discrimination is being discovered in AI systems, everything from women being less likely to be recruited by technology companies, through to an AI system predicting that black defendants were actually twice more likely to reoffend compared to their white counterparts. So human biases have been well documented, and we have today experiments that can measure how much biases can affect outcomes. However, bias in the field of AI is a relatively new search topic. Many argue that AI should in fact help us make fairer decisions and reduce our human biases. After all, an AI algorithm's main objective is to improve predictive accuracy based on the training data that we use to train it with. However, in my opinion, that's exactly where the source of the problem lies. Underlying data, rather than the algorithm itself, can often become the main source of bias. And what I mean by that, depending on how the data were collected and used in the training process, will also influence the produced results. A student is only as good as his teacher, after all. Our own stereotypical versions of human nature and our own biases can often creep in our training datasets and give AI skewed data. Take, for example, ImageNet, one of the most popular training sets in the history of AI. In the words of its co-creator, Stanford Professor Fei-Fei Li, ImageNet was built to map out the entire world of objects. This crowdsourced image library of more than 15 million labeled images has in the past few years been the go-to dataset for training image classification algorithms and has been instrumental in the development and evolution of deep learning research. However, since all images are crowdsourced and tagged by humans, preconceived opinions and stereotypical versions of the human nature still manage to find their way in. For example, Uh, Here is an example of where to train an AI system to recognize computer programs using data extracted from imaging will make the algorithm think that all computer programmers are male and white. And that's because images under this category within ImageNet are associated with male at a higher extent compared to female. So a lot of efforts have been recently focused on the responsibility that we as AI practitioners have to make sure that every model that makes consumer decisions or can adversely affect individuals should be transparent, fair, without biases, and trustworthy. A big part, and this is by no means the only one, is played by making sure that every AI decision is ultimately explainable. Let's say, for example, that I was able to build a very sophisticated machine learning model that was able to predict with 99% accuracy that someone's got the flu. Do we believe that a doctor would trust such a model without questioning how the model reached that conclusion? I believe he or she would try and understand the reasons behind the model's predictions before making any recommendations. Inevitably, when we start using more advanced machine learning models, although we gain in accuracy, we lose some of the ability to explain how the model works behind the scenes. It's really easy to explain to someone how a regression model makes decisions, but it becomes much harder trying to do the same for a neural network, as an example. Explainability is a hot topic right now, and a lot of new methods have recently been developed to deal with this issue, like the ones presented in this slide. These are some popular approaches in research today that help us open up the black box and understand what's happening behind the scenes. To showcase how some of this work, we're going to run a small experiment. I've taken some example data, in this case information about everyone who was on board on April 15, 1912, when the Titanic collided with the infamous iceberg. It created an algorithm that can predict what sorts of people were more likely to survive based on their age or gender or socioeconomic class. I've run the data past a highly complex machine learning, in this case a random forest, which is considered black box techniques, which is not easy to interpret. The final model can predict its passenger survival probability with high accuracy. We will now try and use some of these techniques to see if we can start demystifying the results and start getting a better understanding of the inner works or how the algorithm reaches the final decisions. The first graph we're going to look at is that of variable importance. This tells me that from all the information I have about the Titanic's passengers, gender and age seem to be the most important factors for inferring whether someone would survive the trip. That makes sense in this scenario, as we know that children and women were given priority when escaping the ship. However, this might not have been appropriate in different situations, let's say in insurance. Insurers are not allowed to use gender as a factor when calculating insurance premiums. Let's explore further results by looking at partial dependency plots, which allow us to see what is the marginal effect of each and every input to the target. As we can see from this example, younger passengers were given a higher survival probability by the model. Again, this makes sense given the same scenarios and reasons as above. Once again, if we were instead creating models to predict credit default in a banking scenario, we might expect a similar pattern, given that younger applicants might be more likely to be under financial strain. Let's do a PD plot or partial dependency plot on a categorical variable like passenger class. As we can see from the results, passengers staying in first class have better chances of survival compared to those with a third class ticket. But is this pattern consistent across all groups? ICE plots, or individual conditional explainability plots, allow us to see that although third class ticket holders were less likely to survive, still the model believes that some would have better chances compared to others in this group. These two higher bars in these graphs indicate that we have passengers within the third class cabin that have better survival chances. If we look at this pattern even closer by looking at the individual level, at the passenger level, using kernel sub, which is a more detailed approach to look at the individual level. Kernel sub methods allows, for example, to see that the passenger of number 660, for this passenger, the model thinks that they have pretty good chances of survival. Although they are staying in third-class cabin, which, as we can see, has a negative effect on their survival, the fact that they are younger and female gave them better chances, pushing their survival probability to the right of this graph, which indicates positive changes or chances. I actually looked this up, this particular example, and as I was doing this, it turns out that passenger 660 was Miss Marie Catherine Baclini, who was 5 years old at the time and who has survived. So to summarize, we looked at what terms like AI, machine learning, and deep learning mean, and the value they bring to businesses today. Hopefully, we managed also to demystify some of these terms for you. We've also covered some of the challenges that come naturally with AI, things like fairness and bias, but also looked at how we can start pulling back the curtain on some of those more complex machine learning algorithms, like the example we covered earlier of the Titanic, in order to do a proper audit on how they impact our decisions, which is quite key and important in regulated scenarios within insurance or banking, or cases where we deal with humans. So thank you very much for your time today, and I will be more than happy to take some of your questions if you have any now.
Thank you, Georgios. That was excellent. It'll be great to get you on camera. I can see some questions coming in from you from the audience already. So let's just wait for you to come on. Perfect. Hi. Thank you. That was excellent. Let me. Shall I dive straight in? I can see some questions. So the first one we have here is from Ankesh, and it is, well, it's actually a personal one. So it's, what's the best example of AI in action that you actually love?
That's a hard question. If we compare the ones I presented today, I would say what comes on top is obviously the Amsterdam UMC case. This is a special one. It's a special story. I helping save lives, literally, and using computer vision to help radiologists like detect tumors faster. If I had to choose another more personal one, for me would be a work I was involved with a large public healthcare insurer in New Zealand, where AI models, we use, for example, supervised learning models in order to detect abnormal claims from healthcare providers. So we had healthcare providers trying to play the system or inflate bills by over-prescribing treatment for patients. So obviously AI helped us detect anomalies that were obviously fraudulent for the insurer and helped us save taxpayer money, but also helped us save patients from unnecessary treatment, which would have a detrimental effect to their health.
Mm-hmm. Okay, I've got another one from Nadine here for you, and that is, it's a technical one, I think. What's the best way of picking a champion model out of multiple statistical models in machine learning?
So I think that one would depend on the objective of the project. So there is obviously a trade-off between accuracy, or simplicity, and explainability. We talked about this earlier in the presentation. So you typically would have to run a competition of multiple models and then choose an appropriate measure to compare them against each other, given the business objective or the business setting. So if, for example, you were trying to build an algorithm that can be used by a COVID-19 detection test, as an example, you may choose to minimize false negatives rate. If your main objective is to provide a model for a regulated environment where you typically want a lot more explainability and more simplicity, then you may choose a different approach or a different technique. So it boils down to what the objective of the project is.
Okay. I've got a question for you from Monadeepa, who said it's a fantastic session. It's actually quite a few people mentioning how good it was. And they've asked, what are some of the most topical cases that you can see in banking today?
In banking today, credit risk is one of the most important ones. Credit risk models have been used in the past a lot, but as we looked at the examples above as well, like the computer power now has allowed us to run more complex algorithms and has helped banking credit risk modelers to have access to more accurate models in order to detect those risky customers faster and more accurately. So machine learning can be used within those environments and provide a better approach than what has traditionally been used. Another case is NLP, or natural language processing systems. So we saw the example of RBS, but also a lot of the customers I've been talking to these days are trying to create automated agents that can interact on an online chat with customer bases and understand better their queries and their trouble. So NLP is another great example where machine learning and AI can provide significant value for within banking.
Okay. We've got a question, I can't see who it's from, but they've asked, do you see a difference in adoption between US, Europe, UK and Asian markets, and sort of your opinion on where you see the most traction, or is this more industry-wide, they've asked?
I feel that, yeah, there are definitely differences across different markets, and a lot of those have been driven by the regional regulations. So you may find out, for example, in the US, you can not use highly advanced AI algorithms within pricing, as an example, whereas within UK, as an example, you can't. So we've seen significant uptake from insurers within UK to use more advanced machine learning models within insurers for pricing models. Again, you may not be able to use AI systems for computer vision. I use cameras or image analytics in order to detect faces in some European countries, but in some other regions across the world, there's a lot of uptake of those technologies in order to use them for detecting fraudulent activity or for security purposes. So it really varies depending on the regulations of each country, I would say.
Okay, and there's one from Thomas, and that's what do you think is the biggest challenge that practitioners actually face today when it comes to implementing AI?
So I would say the main challenge I typically hear from conversations I have with my customers is what we call overcoming the last mile. So how can I deploy my models? So we see a lot of time, many departments spending a lot of time and effort and sweat trying to build those highly advanced machine learning models. But at the end of the day, they don't see the value because deploying, actually putting that model into a decision system is quite hard. So operationalizing analytics and making the benefit you get from algorithms such as those repeatable is quite a tricky task. And obviously, we are, as SaaS, can help in this space, and we have many examples where we help customers overcome this last mile.
Okay, I've got a question from Tamara, so I'm not sure if you have, but I'll ask. Have you done any work on geospatial data?
Geospatial data? Yeah. Let me think. So we use geospatial. We use quite a lot of geospatial data within insurance. So I've mentioned before the example of pricing. It's not surprising, depending on where you live within the country, obviously impacts your premium you have to pay.
Yeah, so the follow-up part of that is, if you have, then where are the challenges? So you might want to, if you want to answer them both together.
The challenge, this example is from, as I said, from insurance, right? In order to come up with a premium that you have to respond to a call from a customer, one of the factors is your location. So geolocation data play a major part within this setting. Obviously, the challenge is making sure you don't differentiate in that extent that you provide a separate premium to your neighbor, or it's making sure that the premium you sold them is fair. And when you deal also with geolocation data, the massive amount of data make it difficult when you don't have an environment in order to deal with those. And the last challenge I would say is the quality of the data. So I've done quite a lot of work within those settings where it's quite difficult to even starting building an algorithm because the data are not in an appropriate format. So cleansing and preparing the data can also be a major task.
I have a question for you from Martin, and this one is, do you have an example of anomaly detection in market risk management for capital market companies you might be able to share?
Oh, that's so I've actually worked in one example of that. So I worked in a project where in capital markets where we had to use anomaly detection. We were using anomaly detection in order to detect abnormal behaviors within the market. So we were looking at stock market data, and what they had noticed is, for some reason, we have those spikes or significant drops within the market that last mainly milliseconds, and then they recover immediately. So how can we track that abnormal behavior? Anomaly detection algorithms, such as the ones I've mentioned before, are great examples where they can provide value in a situation like this.
Okay, and there's, I think we're running out of time, so I'll ask you one last question, and it's from Pablo. And Pablo's asking you, what resources would you actually recommend for machine learning and AI beginners?
So obviously there are many free resources online that you can go on Google or YouTube and watch millions of different videos and start from there. That's how I started when I was a student. In fact, we have a lot of many free tutorials online at SAS.com if you want to go there and check. Other online platforms like Coursera provide great courses for beginners to drill further down and understand those topics. We have our own machine learning using SAS Viya on Coursera right now. You can go and check it out. It's a great course. Obviously, if you want an environment to start playing around with machine learning, you can go on SAS.com again and download get free access to SAS Viya for Learners, which is again a great tool to get you started.
That's excellent. Thank you. Thank you for taking the time to present and for taking questions. I think we do have a couple more, so we'll email that across to you. And if anybody else has got any more questions, then please email them to us at hello@worldsummit.ai, and we'll be sure to send it to Georgios, and you get back to them, hopefully.
I promise.
Perfect. And we've got them on your dashboard for the audience. We do have a tab that's called handouts. I can see that there's 3 handouts attached there. So, if anybody wants to download those, and also this webinar will be available afterwards as well, because there's a few people who've made comments saying they'd really like to look at the details of it and see it again, so that will be available for you afterwards as well. And so thank you again, Georgios, and thank you to the audience for joining us today, and I hope you all have a great afternoon. Thank you.
Thanks everyone, take care.